I'm seeing Vishal and Arpita, Roy and Bundas. Very good morning. Already joined. Great. So perfect 8:30. So we'll try to complete in the just morning class. We'll finish the remaining two topics. That is yesterday I think we have not completed precision rectifiers one topic. That is one important area which we are covering today. I'm seeing Vishal and Arpita, Roy. So we'll finish up this topic, precision rectifiers, how to tackle this type of problems we'll see today. And one more area is there called active filters. Active filters, what I'm planning is I try to teach you the table form technique for you because if you know the technique table form, doing the problems is easy. But it is an elaborate subject. Okay, if I want to teach only active filters in the class, it may take 4 to 5 hours actually. If I want to teach each and every step and derivation for you, it will kill the time of the remaining topics. That's why what I'm doing is that has been presented as a recording video for you. That is being uploaded after this lecture today class for you. Okay, so whenever you have free time, you can see how the derivations I have done and how the results are coming. You can see, but in the notes, don't write all these derivations, all these things in the video. Just only the table form technique you write. So that how to tackle the problem, I'll explain you taking one example. You try to understand it, how to tackle that. So the results are very important. So don't waste the time for the topic. How to do it, procedure I'll tell you, and for backup knowledge to understand how this transformation scheme for each filter and how to design that filter. The designs I'll give in the recording video. Whenever you want, you can see that video. Okay, and the notes don't copy the complete video because it's a lengthy video I made where each and every derivation, each and every result I have shown you. But for you, in exam point of view, you must recollect the circuit, you must recollect the result. That is more than enough for the gate exams. Okay, the things we'll discuss for half an hour to cover the active filters. So today by 12 o'clock, I think 10 or 10:15, we'll close the matter of these last two topics. After that, we'll go for a special module, final module called nonlinear applications. That is your today class. Today, if we can complete all the concepts for op-amps, job will be completed. Tomorrow morning, what I'll do is first workbook practice will do it. I think remaining topics are mathematical operations and one more is nonlinear applications. That two workbook problems first will complete morning session. After that, we'll start a new module today. Tomorrow, that is called negative feedback amplifiers. That is my idea. So Friday, we are covering that module with workbook problems. So Saturday class, what I'll do is morning class, I'll try to start oscillators. Oscillators होने के बाद, then we'll go power amplifiers, basics I'll explain. Then with that, we can close the analog electronics. Okay, this is my idea. Let us see now. Anupam is telling lecture number 28 is not opening. Is it happened for every student? Lecture 28. Please respond so that I'll tell you that persons. Open basic part 3 video not playing. Okay. Okay, Samrish, what I'm thinking that last ADC video I keep at the end of the session, so don't worry about that. Okay, at the end I'll keep it. Whenever you want, you can see that video because that is not the primary important for our class. Okay, main importance is not the ADC concept. Analog portion is important. Not opening. 28 is not opening. Okay. Tell then one time I'll tell to that persons 28 is not opening. Note it and convey to the person so that they'll try to recheck it. Okay, don't worry about that. They have already noted it, so no worries. So let us start our journey on precision rectifiers today class. Keep the heading the word precision. Why should I take precision? First I'll give some introduction for you. Let us see. What does precision circuit mean? So why should I take again rectifiers in my class? Means you can see that if I take a normal diode, if I take a basic diode like this, if I use only diode analysis for small signals like millivolt signals, I understood that diode cannot behave. Diode cannot behave as a rectifier for small signals. So this is the first problem with the diode. What we studied in the first classes. Diode, whatever you are taking small signals, I think the minimum voltage required for the diode to be on is 0.7 volts. 700 millivolts is required to make the diode on. But here you are applying without any DC. We are applying only AC signal. That AC signal is also millivolts we are giving. Suppose 1 millivolt. For example, 1 millivolt we are giving. So 1 millivolt if you go, the diode cannot understand that signal. If the diode cannot understand, I think it will not perform as a rectifier. Rectifier means it has to become on, it has to become off like that. But it is not performing. This problem, our op-amp engineers has been notified. And the op-amp engineer said that we can make the diode to be on and off by small signals by taking the help of op-amps. Operational amplifier I take and I'll make the diode on and off inside. So how you can make? Suppose if I have now a signal like this, 1 millivolt signal. So what is my technique here is, I'll just use op-amp now. I'll keep op-amp here. And suppose if the op-amp is operating under open loop conditions, open loop, your AD is very high. In open loop system, AD is very high. So whenever I give a very small input, but the output will come as plus or minus V saturation. So this is the knowledge we have in electronics. Suppose if I use op-amp design, I have given that small signal to not diode, to the op-amp I have given. As you know that open loop system op-amps are very high gain. Just a small input, 1 millivolt also if you give, I think it will go to saturation output. So this is the logic which I want to use in my class. So I'll give a small input, but I'll make it as a big output, DC output. So whatever the answers you got, plus or minus here, that makes to connect to a diode. Now I'll connect to the diode. If I connect to the diode, if I interact this output, suppose your output is plus, then this diode will become, I'll keep here some load. I'll keep some load here. This is your output. So this is a rectifier circuit I prepared. So with the help of op-amp, a small input, I have been magnified to plus V saturation. This plus V saturation minus V saturation will make the diode to work as on and off. So diode will be on for plus V saturation, and diode will be off for minus V saturation. So it will be on and off. Whenever one time it became on and off, automatically diode will behave as a rectifier. So this is actually the story how they apply electronics with the diodes. So a basic diode cannot do that work, but with the help of op-amps, if you use the principles of open loop system analysis, automatically the diode is working for small signals also. For small signal also it is a rectifier. So such type of accurate rectifications for small signals also if we can do, we call the systems as a precision rectifiers. Okay, so accurate we call it as precision. Very small signals also the systems will rectify it. That is a beautiful concept. Precision rectifiers. So this rectifier we call it as precision, accurate precision rectifiers. So where we use this application generally is in your biomedical called ECG, where you apply this designs. In your, I think, medical centers, whenever you go, okay, hospitals, wherever you go, there is a site by doctor, whenever he is checking the heartbeat rate, all these things, you'll see that the instrument called electrocardiogram, ECG we call. So in our mobile phones also now if you see, okay, Apple series, I think they have launched in iPhone, I think iPhone series watches are coming now, series watches, around 6 series, I think 5 series, 6 series, 7 series, we have this ECG, we can check it ourselves, okay. If you can have a watch on your wrist, you can check ECG by yourself. That much the technology has increased. But previous years, we have instrument for that. Now in the watch itself, we can check how much the heartbeat rate for you. Every instant of time, you can check it. Okay, that is the beautiness we have. So ECG we call electrocardiograms. In that, whatever the heartbeat rate you are getting, that will come like a small signals. That has to rectify it and it has to convert into DC value. Then this type of instruments they'll use called your precision rectifier techniques. Okay, so this is one of the beautiful technique which we are trying to develop it today. How the question will be and how to tackle it. That is the concept. I can teach so many circuits. That is not the meaning today. I'll teach half wave, full wave, two issues for you today. But half wave, full wave, I'll teach. But person can ask you different angle of questions. But the story should be same. Whatever may be the question you ask, my principle should be same. That's why today I'll try to develop two concepts. One is half wave lecture, one is full wave. With that you try to understand it. How the methodology we are going to analyze. That is important. So let us start the course. First half wave will start, then I'll try to show you the proposal, how to design a full wave using precision circuits. There is no rule that I have to ask only rectifiers based on these topics. I can ask you clippers, I can ask you clampers, I can ask you peak detectors. They're all routine thing. Because the peak detector, what it will do, you know the answer. Outcome will not do anything. Just your result, what you got peak detector in old classes, that should be the answer. Clamper, what is output you got in previous class, that is the answer. So no need of teaching all these issues, but rectifiers compulsory we have to teach because it's a new thing for you. Okay? Clippers, all these things will come from basic circuit designs. So directly you will get the answers. But these issues, try to understand how to make this concept. Precision rectifier, in the exams they'll ask you how to do this concept, you'll say. So I think you got clarity now what I want to convey the information. A small signals, whenever you pass to a diode, they will not try to rectify the signal because it does not have an ability to be on, but it has an ability to be off because it requires a cut-in voltage of 0.7 is required. Okay, diode requires a cut-in voltage will be there for this type. The cut-in voltage of this diode is 0.7 volts. So you have given only 1 millivolt, so it cannot be on. Okay, but here plus or minus Vsat, but the diode cut-in voltage is only 0.7, but my V saturation is very high value. This answer is more than this. That's why the diode can be on, can be off. We can do it. Okay. So let us understand our today problematic subject. It's very easy and a comfortable topic, so no worries. So let us start with the first topic today. That is half wave circuit designs, how to do by using precision circuits. We'll try to understand it. Okay. Using precision circuits, how to design this concept. So let us move to the concept. So first one, I'm starting with the half wave. Half wave precision rectifier. See the procedure how to make a half wave precision rectifier circuit. For this design, what happens is the PAV will come as a high value. That's why we have to modify the circuit. Because PAV, whenever you get high, there is not advantage, there is disadvantage for your circuit. Because the cost will increase. If PAV is high, please remember for any circuit you got PAV high, that means the cost is more. Cost will be more. So I think maybe this circuit will be a drawback. I'll rectify it. Cost will be more will come when the PAV is high. So in this circuit, how PAV will be high, the things we'll discuss. First see the circuit. The person started to design a circuit like this. This is a plus, minus side. I connected a diode here as a feedback with a load called RL. You're taking this as output across the load. This is op-amp output is VA. Take two different outputs. This is op-amp output, this is your load output. In between there is a diode. Now I have given here a signal called VIN. The VIN signal is 1 millivolt suppose. Now you have to rectify the signal, small signal. So examiners will give questions like this. They'll give op-amps, they'll give diodes, sometimes they'll give BJTs in the workbook you have seen. Whatever maybe they are keeping, what is the principle behind this? First I said is, first op-amp should work like an open loop. Then only these results will come. Then only I can check the diode I said in the class. But if you see a diagram, it looks like a closed loop initially. But how to make it open loop? Okay? To study this class, the op-amp should look like open loop first. For that, what is my theory here is, assume always the device to be off. Assume diode is off. So whatever may be the devices they are giving here, BJTs, diodes, whatever may be, you just make it off first. When you make it off, the diagram will change. So this will become plus, minus. You see open here. You see a load. This is your output. This is your VA. And this is your input. Perfect if you observe, this is an open loop system now. Assuming diode is off, it became an open loop. You can see clearly, it's an open loop. If it is an open loop, okay, your AD inside is high. Op-amp AD is high we have taken. So can I say that there will be no current flowing to the load because we don't apply any voltage here. So current is not flowing here because this is ground, there is no potential here. So no current. If there is no current, this RL will get shorted and the same model we can present like this. Modified circuit. You can see the modified circuit. After making open, this model can also be represented like this. This is plus, minus. Minus directly you can make ground. This is your input and this is your VA. Perfectly if you see, the circuits will become like this in the classes. Okay? The load is shorted, IL to 0, this is ground actually. We're going to take ground directly. This model you can show like this in the class. Okay? And you said that AD is high here, AD is high. So it's a perfect open loop system now. If it is an open loop system, it will be used as a comparator I said. It will be used as a comparator. What is the meaning of comparator here? Your VA, V plus is not equal to V minus. It is a comparator because V plus and V minus both are not same in the class. Okay, this is 0, this is signal. Here give. This is signal. So why can't you use comparator analysis now? This becomes VD difference. If your input is suppose greater than 0 happen. If input is greater than 0, we are applying positive cycle. If this is dominating this, then VD, your difference of the op-amp will become positive. Simply VD will go to positive. Comparators are easy to understand. Okay. Comparator. Jahnavi input you can apply to non-inverting also, you can apply to inverting. This example I have taken for non-inverting. In the next problem I will go for inverting. There is no rule. Anywhere you can apply. Okay. This example I am taking for non-inverting input. So VN greater than 0. VN greater than 0. VD is positive is coming. The difference is coming positive. Then automatically your VA output will become plus V saturation. This is the answer we are getting. VA is going to be plus V saturation. Whenever you got here plus V saturation, here is ground, you said this diode is telling I'll be on. Diode is telling it will be on. So this is the meaning what you have to understand the class. Diode will get on. Because of plus V saturation at the anode, the diode will get on. If the diode is on, I think now you can replace your model like this. If diode gets on in this area for positive signal, your model changes like this. This is VA. This will be positive or negative. I keep some cutting voltage, 0.7 volts. Diode has some cutting voltage, 0.7. It is getting on. And finally you have the load. This is your load. This will become your output. This is your input, where you have given the positive cycle in the class. So for positive cycle, the diode is getting on. So what is the output for this question means? Have you seen that this is just looking like a buffer? So it's a closed loop now. This is a closed loop. When diode gets on, it becomes a closed loop. For a closed loop, I think this point will be same. Virtual ground applied for closed loop system. So you can write here, output will be equal to input by the concept of virtual short theory. Virtual short, because the system is under closed loop now. When diode gets on, it is closed loop, so I applied the virtual short. So output and input became same. This is called a buffer concept applied. So finally, whatever you are giving the small signal here, that is coming to the load output. Somebody asked me what is VA in this problem. Op-amp output will be 0.7 plus VIN. This is your VA for op-amp output. This is op-amp output. In the exams, if they ask you, please tell me the op-amp output, you have to tell that 0.7 plus input will be the VA. This completes my positive cycle reaction. Now come to the Rahman, who said like that here? Inverting, non-inverting, anything you can use, there is no meaning for that. First classes we have made a hobby to teach any one manner. Inverting if I teach, non-inverting if I teach, will get confused. That's why most of the times I teach with inverting like that, I done it. There is no meaning. Inverting we teach कर सकते, non-inverting. Okay? Inverting में भी error होते, non-inverting में भी error होते. इधर ये models को हम inverting बना सकते हो, non-inverting but I'll do both the things. You try to understand it. No meaning that it's an error. Error will be there for every op-amp. It's not the meaning that I have to use only non-inverting or inverting. Anything you can use it. For study purpose, we do with one angle like this. So this is my answers. Now second one, your input is suppose less than 0 we applied. Negative cycle I applied in the class. So negative cycle means VN will become less than 0. So this difference will become negative now. This difference will become negative. Then VA becomes minus V saturation, it will go. When it be V saturation negative, the diode will come into off. The diodes will be off for minus V saturations. So finally, if the off comes, I think if off comes, your model looks like this. This VN, this minus, this VA. Okay? You have open here. You have open with the load. This is RL. This is your output. So this is the situation you have seen. It's open. Whenever it is open, can I say that there will be no current here? So output will become 0. First point. Output is 0. Nothing, no response. But what is VA here? Your VA will go to what? VA will go to minus V saturation will come because it's an open loop. So in the second case, the diode is off at the time. The op-amp is working under open loop. Here it is working under open loop. So sometimes it is working in closed loop. Sometimes it is working in open loop. So now what is the meaning of PAV here? Peak inverse voltage is the voltage across the diode when the diode is open. How much the maximum voltage is called PAV. If you see the PAV here, if I calculate, the answer is coming to be VA. The answer is VA. VA minus V0. V0 is 0 there. So VA is nothing but minus V saturation. So VA is minus V saturation. But PAV is generally we say magnitude wise. So you can write magnitude wise this answer. In place of writing signs there, better show the magnitude answer. You just show the magnitude answer. So PAV, we are getting V saturation. So that is the meaning what I am telling in the class. When the diode gets off, the complete saturation voltage is going to the diode. When it goes, I think he's telling that the cost of the diode will increase, so that the system cost will increase. So today we have to propose a half-wave rectifier once again, such a manner the PAV has to reduce. That is the next proposal I am giving for you. This proposal is not a good proposal. Why? Because it is giving PAV rating plus V saturation. Plus V saturation means it can be 10 volts, it can be 15 volts, it can be 20 volts. That much PAVs we cannot bring in diodes. So this is the main drawback of this half-wave system. So this completes my total approach. You can see how much easy and comfortable this topic. Sometimes closed loop, sometimes open loop I am applying. So what is the transfer characteristics if you see? It looks like this. This is your input. This is your output. According to the mechanism, what is the answer I got is positive half cycle we are getting output is equal to input we got. Negative half cycle we are getting output is equal to 0. This is called as transfer characteristics for this picture. In the exams they will ask you transfer characteristics for the systems. Transfer characteristics. So this completes the vision about this topic. Transfer characteristics. So you can have any problem given in exam, you can do like this procedure step by step. Let us see the second topic also, you will get more confidence. This is the first design I done it. Now examiner can make this diode upward also. Okay, diode को upward कर सकता हूँ. When diode is upward, what happens? These conditions will become reverse. Because when diode is upward, when the VA becomes plus saturation, the diode will become cut off. Okay, it will become reverse graphs. The things you can do it afterwards. First, basic knowledge is important to teach. Other things are the very common things. When you keep upward, plus V saturation will make the diode off, minus V saturation will make the diode on. So already diodes basics we have. We can do this type of questions. It's not a matter. Okay, take this as the first concept. Where the drawback of this concept is PAV is high we are getting. PAV high is not good for us because the cost of the diode will increase. So let us rectify this concept. So complete up here, we'll rectify this concept. So clearly note the step by step. In op-amps, anything you can take, okay? Inverting will accept, non-inverting, there is no worries for that. Anything you can take. The only thing is positive feedback you are applying, or open loop you are applying, or a negative feedback that will distinguish the application in electronics. It is not distinguishing that inverting if I use, my application will change. Non-inverting if I use, my application will change. That is not the meaning. Anything you can apply. Because I cannot teach both the systems at a time, so whenever I teach some amplifier techniques, you can see inverting we teach here, non-inverting, and differential so many things I taught you. But sometimes when I show you applications like mathematical operations, at the time integrator, I have shown you negative integrators. Okay? At the time student will get it outside, positive integrator, pure integrator. So that is the meaning. Yes, it will become a hobby for us to design that as a negative integrator. Because negative or positive both will do the same. So why to design two things always? Let us make one thing. Like that we done it. Yeah. Yes, Roy, if the diode is upward, you'll get a negative graph. You'll get like this. The transfer characteristics will come output equal to input here. That the positive cycle will be 0 for it. That is the only thing will happen. So just I'll give a note otherwise. Just a small note I'll give for the problem. Yes, Sridas, what you said is exactly correct. Here, no current is flowing. Here, no current is flowing because in op-amp, no current can enter. And not only that, there is no potential also here in the class. If you don't give any potential, no current will enter to the op-amp, so I minus will be 0. If I minus 0 means I equal to 0, then in the port. Okay? So this completes the situation. If you want, you can write here only. That note also you can write here. Same diagram in the exam. Suppose they have asked you for the note, you can take a small note. Suppose if they give op-amp like this. This is plus, minus, this is VIN. He kept the diode upward suppose. This is VA, there's a feedback to the load. Suppose the question is given like this. Don't get much thinking for this. You can just write a graph like this for this. This is my input, this is my output. In positive cycle, diode is off, negative cycle it will be on. So straightforward answer like that. Positive cycle you will not get any response because output will be 0. But negative cycle you will get output is equal to input. You will get like this. So you must have some vision to write this answer. So without doing complete analysis, just vision wise I have written the answer. So if it is upward, that is a story. A downward, upward, two things will come in this design. Yeah, Shubhrat Radha, we can make clippers also using op-amps. Okay, से बना सकते चाहिए तो एक मॉडल बना दो, आपको अंडरस्टैंड हो जाएगा. So no worries. Clipper also I'll take one example to get an idea for you. First rectifiers complete कर दीजिए. So first rectifiers complete करते clipper भी एक design I'll try to teach for you how it is going to happen. A clipper circuit. Clippers and rectifiers have only one difference. Clipper means any part of the signal we have to keep it, but rectifier means we have to keep only 50%. Okay, that is the difference between a rectifier and a clipper. Rectifier and a clipper. So let us see how to solve this problem. PAV, how to reduce here. We are getting high PAV here. If you get a high PAV, I said it's a drawback. You just add here, it's a drawback. High PAVs are not preferred in my designs. High PAV, you write it as a drawback. You just add this point in your notes, drawback you go, PAV is drawback here. So let us move to a proposal, I'll change now. Okay, half wave only I'll design, but proposal I'm changing for to get less PAV what I'll do. So let us see the next special design. Again, modified we can say, modified half wave rectifier. Modified half wave rectifier, but with PAV less well. How to make PAV less in a half wave rectifier? Let's see. Suppose if I take design in this manner, this is the diode. Now I'm using inverting system, not non-inverting. See the concept. Whatever I like, I can change the designs. Negative side and take my action. Here we have resistor. This is R. This is my input, VIN. Here I'm taking a diode as a feedback, D1. And we'll take another diode, D2. Here multi-diodes are coming. Here we take one feedback resistor, R. And we are going to take to the diode output. This is output. This will become your VA, op-amp output. So this is very special design, which will be in electronics. You have to understand it. This is called a modified dead-end for half-wave rectifier to reduce the PAV concept. PAV we are getting plus saturation or minus saturation. Let us make it a small value. How to make means I have taken the help of two diodes for this process. So please draw it in a similar manner. How I'll finish this topic we'll see now. So first concept we have to do is assume that it should be an open loop icon first. So assume D1 and D2 should be off. This is the procedure you have to apply. Whenever D1 D2 are off, the diagram looks like this. This minus, this plus. Plus is grounded. Minus side is R. We are giving some input as VIN. And here we have open. And we have one more open with some resistor R to the output. This is your output. So carefully understand the switching positions like this. This is one diode here, which is a D1 diode. And we have one more diode is D2 diode here. And we have here VA potential. This logic will help you to answer the question. Now the point is, the system is under open loop. The system is under open loop. Because I just opened all the diodes. It will work under open loop systems. Okay? If it works under open loop, just a person should know in which cycle the diodes will be on. You have to tell to the person. Then what's my trick here is, suppose if my VIN, I'll write here, if my VIN is a positive cycle, VIN is a positive cycle applied. Use the common sense here. Okay? Common sense is very important. You apply the positive cycle to the inverting side in the class. Whenever positive is given to inverting, okay, then the positive will become a negative here. VA will become minus because you are going to the negative side. So therefore, your VA will become minus V saturation. Simple point. When input is a positive cycle, you have used the inverting amplifier technique, so it will go minus V saturation there. Whenever it is minus V saturation, the cathode of D1 is connected to minus, anode of D2 is connected to minus. So you can see the technique now. Cathode when it comes to negative, it will become forward bias. If anode is connecting to negative, it will become reverse bias. This single point will help you to catch these points very easily. This is cathode here. This is anode. You got a negative sign here. Negative sign when it touch anode, the D2 will become off. When negative touch cathode, it will become on. This is the way how we are checking the points. D1 is on, D2 is off. Nicely we completed the testing of diodes. Very simple testings there. Okay. D1 became on here, D2 became off here. So let us write the model and see what is the output for this. Concept is completed. This is minus, this plus, plus is grounded. We have R, this is VIN, and we have a battery of 0.7, and this is open, and we have a resistor R to the output. So this is the position I'm seeing. Okay. One diode is on, one diode is off. So what will happen is, this is virtual ground, we can take 0, because it is in closed loop, YSID is, it may be open at the final stage of feedback, but it is closed here in the inside closed loop itself. So it's a closed loop, it's not open loop. So virtual ground you can apply, it's a closed loop, first confirmation. Maybe one feedback loop is open, but one feedback loop is not open. So diode has closed it. So it's a closed loop. So virtual ground easily you can apply it, and the current cannot go to this side, 0, because the current will go this side. The same current, II, will go to this I diode, because the diode is under forward bias, which will show the low resistance path to pass the current. So the diode will take the complete current, because it's a short circuit, or practically we can say concerned with short. So our resistor will not have a chance to take the current. So can I say that if there is no current going here, your output can be written as a 0 volts. 0 minus I into R is 0. So output became 0 in the class. This is the trick for the first concept. So positive cycle, it is not reacting actually. So when input is negative, suppose, negative cycle, your VA becomes plus V saturation. It is opposite. If I give a negative cycle, the saturation becomes positive. So positive is connected to D2. This will become forward bias now. Positive is connected to cathode. That will become reverse bias. So opposite. So D1 will get off now. And D2 will get on. Situation became opposite. Okay. And D1 is off, but D2 is on. So the model looks like this. Model looks as minus plus. Plus is grounded. This is resistor R. This is VIN. And we have this is open now. D1 is open here. And this R is connected the battery of 0.7 to the output. Can you see that? Again, the system is telling I am also in closed loop. Maybe this is open, but this is closed now. So that is the thinking how he done it. Previous topic mein kya ho gaya? One cycle, positive cycle, diode is on. So it is a closed loop. But when it gets off, it's open loop. But here what I have done is, by taking two diodes, for one cycle, D1 will close the loop, and another cycle, D2 will close the loop. So when you close both sides, what happens? You will not get plus V saturations. You will not get minus V saturations. Therefore, PAV value will depend not on the saturations. It depends on the 13 voltage of your diodes now. So see the trick now. If I want PAV here, suppose, I want to know PAV here, how much? You can see, PAV is how much for this? It is 0 minus 0.7. So this answer will be minus 0.7 will come here. So minus 0.7 and 0. If you see, the PAV maximum can come 0.7 volts. Maximum can come 0.7. So the PAV rating I have been reduced from plus saturation to 0.7 volts. That means it is reasonably a good design compared to the previous topic because it's a very high PAVs, a very small PAVs. That is the trick he applied. So finally, what is the result for this is your output is coming as input here. Can you see that it is just looking like a phase shifter in our class? Amplified designs, we have done fourth topic, phase shifters. Phase shifter is nothing but equal resistors. It will give the same output, V not equal to VIN, but with a negative sign. You get a phase shifter output, V not is equal to minus VIN will come. So this is my output. This is my output. So like this, we got the half cycle again. So what is the transfer characteristic for this? How to show the transfer characteristic for this concept? If you see the transfer characteristics for this is my input, output. For the positive cycle, no response. Your output became 0. So in this topic, what happened is positive cycle will not come. But anyway, you want half wave, anywhere you can bring it. So positive cycle, I will not give response for the circuit, but the same half wave will give in the negative side. But how I give in the negative side is, actually, if you want output is equal to input, this is the equation. In the negative side, if output becomes input, that is your line. But I am not getting like that. I am getting V not equal to minus VIN. Means whatever you have this line, it just phase shifted in the above side. Just it is shifted. Negative to positive sign. So this is called output equal to minus VIN. So this is the way how I brought again half wave in the class. Okay. How the style of half wave I brought is in the class. If you have here, this is your signal, like this you have here. This is your signal. My output I brought like this. Positive cycle, I just omitted it. I'm not bringing this. But negative cycle, I'm not bringing as a negative. You want just like a positive cycle. So I'm just bringing like this the class. So you can see again a positive cycle. So a positive cycle I brought it. So this is the way how this modeling I have done it. So these are called variety of ideas in your analog circuit designs. So a PAV of high value I can bring it to low value with a special circuit in electronics. Maximum times this question has been asked. So you should have a clarity that this circuit should be used for what standard designs there. Okay. This is called as your technique called as half wave technique, and it is going to shift the negative cycle to positive. In exams, if you have the standard knowledge directly, you can just pick the answer for it. That's the first standard models I'm explaining for you. Okay. So this completed the story of your second concept. Let's see the model number 3 that is called full wave rectifier. Also, I'll give a proposal for you how to design a full wave. That also I'll explain. It is somewhat big circuit compared to this. Let's see. That also how I'll tackle. I'll show you the full wave expression. Till now we have done only half waves. Now a separate proposal for you. Full waves also how to design it. Let us have an analysis for it. So you can see how much enjoyment we can do with this problem. Says simple logic. You have to check the type of questions with anode cathode technique by VA voltage. Then easy. Everything is easy. Only just applying the potentials. You will get the answers for this. That's why this type of questions comes in gate exams. You have to feel more happy that we can do this question perfectly. Okay. Maximum years they'll ask you this type of questions. Okay. There is a good chances of asking precision rectifiers. That's why these questions you just tackle with this knowledge what I'm teaching in the board. First rule number 1 for this area is you have to assume all the devices to be open diodes, any number of diodes, so that it will work as an open loop system. We'll get some VA voltages. From that we'll check the diode positions and we'll make it on and off according to that. We'll get the results automatically. Okay. So this completes my 2 topics. इसमें थोड़ा लॉजिक यूज करो अब VIN अब दे रहे पॉजिटिव कॉमन सेंस यूज करो लॉजिक here there is a concept called inverting. You are giving the signal to an inverting system minus. When the input is minus, you are given the signal automatically it will get a negative answer. It will get negative answer because plus is interacting with minus. When plus is interacting with minus, it will be minus. Positive is interacting with negative. Okay, then automatically the answer will be negative. So if you multiply these two things, suppose positive quantity into negative quantity, it will become negative quantity or not. That's very common sense actually. But just multiplying these two things. So that logic you apply. Okay. Ashwan Sahu, nothing to explain here. Again, what is the meaning of asking here? This anode, this op-amp voltage, suppose you got negative. It's a negative RA. When negative comes, cathode is negative. Cathode is negative is forward bias. Anode is negative is reverse bias. These things we have started from starting of my classes. Again, you should not come back and say that what is happening to the diode. Okay? These are all the silly things at this level for you. Because you have learned the subject in such a manner, your depth is now high in this class. So don't bring this type of silly things in the classes again. That means your practice session is not good. I can think like that. Anode cathode say, पता नहीं के लिए why you are getting that much pain here? These are all the silly things for you. From starting onwards we are studying. A lot of subject I got for you. Okay, a lot of information I completed in the class. So this should look very easy and comfortable at the final stages. Okay? You can see a lot of content I explained for you. Yesterday first video is not opening. Yeah, the content team is taking care about that, don't worry. Okay? They are trying to recheck it and they'll send you. Swati something, definitely they'll recheck it, don't worry. They have noted that point, so you don't worry. So please complete this. We'll go for last issue called how to make a full wave rectifier. I'll explain. How to make a full wave rectifier is the concept. How to make a full wave rectifier. So I think maybe today you can expect, okay, by evening it will be open, don't worry. By evening they'll try to open it, don't worry for that. So you can expect if it is completed, let us move to the next point. That is a full wave design we'll make it. So see here, full wave rectifier. Full wave rectifier. My proposal, how I'm going to give a proposal for this, see here. Full wave rectifier design. I'm giving, see the concept. First to draw the circuit neatly, the proposal is given like this. We have inverting technique only will apply once again. Otherwise, we'll go for, take this as output. We have minus here, we have plus. Plus side, I'll make it ground. Phase shifters I want, so negative side will operate. We take this as R, and we'll keep one more R here. Two R's, equal R's you take. And we have a diode here, D1. And you take another diode. This is a D2. And join from here, one feedback resistance. There's one more standard design called half wave. In exams, this is also half wave circuit actually. There's one more way of designing half wave circuits in positive side. You get a positive side cycle here. So this circuit also we'll analyze now in the class. We'll analyze this circuit also in the class. So this is your VIN. Next, what I'm going to connect here is, I'll extend this with a resistor R to the another op amp, minus plus. This total will be joined to this point, and I'll take a resistor R to the output. This is op amp A2 you take. This is op amp A1 you take. Suppose if this much of big circuit given, also how I do the problem. Let us see the concept. So this is a somewhat bigger design. You see, with the two op amps I designed it. Examiner may make this into two half cycle. This off, this off. But if I make full, you can get today a full wave, you can understand how it is going to come. Okay. This much of big circuit, it may be bigger or small. Don't bother that. You apply the procedure. Okay. Draw this diagram neatly. We'll start applying the concept. First of all, our job is to open this diodes. To check the diode positions. First we have to open it. Let us redraw it. Let us redraw. Minus plus. Plus is grounded. We have a resistance here R. This is VIN. We have a resistance R. We have open here. This is VA. We'll take. And we have open again. And which is connected with R. The next we have R. All these things are not required because at this moment I am checking the diode positions. So leave this circuit. We are not interested about this. We are interested here. First we are checking the point. Diode status. So the remaining part is not required. Here only my requirement is diode status first we'll check. Up to here you can check it. So don't make energy wastage here. That A2 control region, A1 could test the region, diode positions immediately. I have to check the position of D1 and D2 diodes. So why don't you use the same logic? Whatever I explained, same logic use karo. Positive cycle mein which diode will be on, you have to explain. Negative cycle mein which diode will be on. Seeing the board, it's very comfortable again. You are giving signal to the negative side. That logic is enough to explain. When positive, you are multiplying with the negative. The answer will be negative. So answer will go to negative here. So let us write that point. Just roughly I'm writing here. Positive half cycle. Positive half cycle. Okay. For positive half cycle, as VA becomes minus V saturation. For positive cycle, I'm getting some information there. Minus V saturation is coming. When this answer becomes negative here, when the answer becomes negative, the cathode is connected to negative. When cathode is connected to negative, it will become forward bias. If anode connects to negative, it will become reverse bias. Okay? Problem is very comfortable. So we can say that D1 will be on, D2 will be off. First case I got the switching positions like this, positive cycle technique. So negative cycle, if you see, negative half cycle, your VA becomes plus V sat. So that means this answer became positive now. So cathode is connected to positive, anode is connected to positive. So this diode D2 becomes forward bias. So D1 will become off, and D2 becomes on. So this is the way how much simple you can do the problems. One time if you know these two cases, we'll apply the two cases by applying the diode models inside and we'll finish the problems. In this concept what I'll do is, to make it easy the concept, assume D1 and D2, ideal I'll do the problem. Otherwise cutting voltages will confuse you. So this question generally, if the question becomes very big, then make the question as ideal diode models. So let us understand in this question, we use ideal technique called diode. If it is on, we'll make short, diode is off, we'll make it as open circuit. So please note down up to here. Testing is completed. This is my testing positions. Positive half cycle, whenever you apply, your VA op amp output will become, even op amp output will become minus V set, such that D1 will become on, D2 will become off. That is the first story. If negative half cycle, if you apply, VA becomes plus V saturation, D1 will become off, D2 will become on. Concept is this one. Now we'll do two diagrams to answer the question. First diagram for D1 on, D2 off, a diagram liquor. What is the output for that? That is the case 1. Case 2 we'll make D1 off, D2 on, and we'll finish this problem. Like this, you can do the problems now. So please note down up here. In the next slide, I'll finish the answers for it. Just your talent is how to check the diode is the talent. That's not a big talent, I think. They're all very small things from diode analysis. Just only one thing you have to remember, when anode is connected to positive, we say forward bias. If anode is connected to negative, we say reverse bias. Like that, practice the polarities first. So let us redraw the same diagram for case 1, case 2. Two cases will apply. Okay? Case 1. First case 1. We are applying for positive half cycle. Positive half cycle. Case 1, for positive half cycle we are applying. So the model looks like this. The model looks like this. This is negative, this is positive. Positive is ground. We have a resistance R, and this will become short. Your D1 is short, but D2 is open. D2 is open here. And we have a resistance here, R. This is your VIN. One point, please observe here the concept very clearly. Don't write this diagram, just I want to tell you first the logic and then simplify it for you. This is the resistor R you know. So please don't copy it. I'll tell you a trick for this. This is the R connected like this. And the same R is going to the op amp. This is the next op amp, positive. Can you apply some principle here in the class? This is a closed loop system. Whenever there is a closed loop system, we'll have zero virtual ground. Correct? Virtual ground will be there. Now if I say that the signal is coming here, the current will pass to the op amp here. It will go like this. But I can say that for this side, the current will not pass. Because this current is directly focusing to the non-inverting op amp, where it's a high input impedance device. So current will not accept it. So if current is not going like this, why you are writing this much lengthy concept? This will become short, this will become ground. So why to write like this? That is my idea. So why can't you disconnect all the stories? Disconnect all the stories and write like this easily and comfortable for you. That will become nice for you to write. So this is the position. What I'll do is just I'll make this as ground. Without connecting like this, I'll make it ground. So you got a separate action now in the class. Okay, separate action. This is open for you, and this is ground, and we have a resistor R here, the minus, and there is R to the output. So can you see that the model became like this? You separated the conditions. So this ground I just made here ground. This is also ground point. Okay, so you can see two separate circuits now. This is A1, this is A2. So this is the trick you can follow for the first cycle. Without writing like that, we just make the action cut into two parts. If you have any doubt, you just redraw the previous diagram and draw it like this again. Okay, so this is the circuit we have. Now if I ask you, what is V01 here, or VA how much? What is VA here? So this is just looking like a phase shifter. Op amp A1. Op amp A1 output is phase shifter. It is minus R by R into input. So VA becomes here simply minus VIN. So op amp is a phase shifter we got here, minus VIN. And op amp A2 if you take, op amp A2, it is becoming output is equal to, it is also becoming a phase shifter. So answer is minus R by R into VA will be the input. Second output, the input VA will be the input for it. Okay, this will be the input for it. So answer is minus VIN. So output will be equal to VIN. So this is the proof for positive cycle. The reaction is completed. This is a positive cycle reaction. So whatever you are giving positive, that is coming as an output for the positive cycle. So this completes my first analysis. Let us make the second concept, that is case 2. Side by I'll complete one more case. Case 2. That is a negative half cycle. Negative half cycle. If you go for negative half cycle, the diode model will be like this. This minus plus is grounded. We have a resistor here R. This is VIN. Okay. Next we have is a resistor R. This will be open. And we have resistor, sorry. Here we have the short circuit. We have a short here. This is D2. And we have a resistor R. This voltage will take it as VA voltage. And it is connected to op amp. Minus plus. This is output. So like this you are seeing the second diagram. D1 is off, D2 is on in this case. So the point here is, can I write this potential? Here is VA now. This is VA, you can write. The same VA will come here. Both are same. According to virtual ground, this also becomes VA. There are closed loop systems. So the VA points are coming like this. And according to this closed loop system, this point becomes 0 volts. This is 0. So you can apply KCL for this. One current is entering this side. One current will come VA to ground side. And one current will come VA to ground side. Three currents are coming here. You can apply KCL at V minus. This is one current, this is one current, this is one current. So KCL at V minus of op amp 1. In op amp 1, I applied a KCL for it. Then answer will be VIN by R, one current, plus VA minus 0 divided by 2R plus VA by R is equal to 0. So this is the KCL I applied, simple KCL. You can find out the relation between VA to VIN in the class. So if I want to write, this all becomes 2R if you want. You can just write 2 by 2 here. Here also 2 by 2. Just include 2 by 2. Then what happens? This bottom terms are same. So just cancel these terms. It will become 0. So you have only 2 VIN plus 3 VA is equal to 0. Then VA becomes minus 2 by 3 times of input. So this is my VA knowledge. So VA we found like this. But this VA is nothing but the input of A2 op amp. It is an input of A2 op amp. So second one is a non-inverting amplifier. Second one is a non-inverting amplifier. So op amp 2 is a non-inverting amplifier. Non-inverting amplifier. So you know how to solve non-inverting amplifiers, correct? Op amp A2 is a non-inverting amplifier. So what is the answer is V0 is equal to 1 plus RF by R1 into your VA is the answer. 1 plus RF by R1 into VA. Here what is RF, what is R1 is? This became your RF and this became from here to here. It became your R1. These are your R1 RF positions. So answer is 1 plus R by 2R into VA. VA is minus 2 by 3 into VIN. So if you solve this problem, it is 3 by 2 is coming. So this total will cancel. 3 by 2 into minus 2 by 3 into VIN. So finally the output is coming minus VIN. So finally I proved that. Here also your output is coming, but is getting phase shifted by minus VIN value. So the first result we got V0 equal to VIN. The second result we got V0 equal to minus VIN we got in the subject. So So this is a story about how to write the output values. So with this, I think the transfer characteristics, if you observe clearly how you are getting transfer characteristics, I'll show you here. How the result you can see the transfer characteristics simply, I'll show you here. The transfer characteristics will be shown like this. This is Vin, this is V naught. For positive cycle, we got the output is equal to input like this. But negative cycle, we are getting phase shifted your input output. So output equal to minus Vin. So this is called as a full wave rectifier. So both the signals, positive and negative, are coming in positive positive. That is called as full wave rectifiers. I think this is the graph you are getting in the class. That means you applied your signal like this. This is the signal you applied like this. But my output result is coming like this. My output is coming in this manner. Positive is coming as positive, but negative is also coming as positive. So this situation, we call it as full wave rectifier analysis. This is more than enough for this area. Any person can do the problems based on this. Okay, whatever may be the question you ask now, I'll solve it very comfortably. Because any number of questions we can design for this. But these are called standard designs, we can say. From this only they'll try to ask you the model designs. That's why if you have grip on these three models, it will help a student to do this area very well in the exams. Okay. Somebody asked me about Clipper example. But maybe Clipper example if you want. That extra things I may send you in WhatsApp. Okay. One or two examples I send you in WhatsApp, you try to understand it. Here I don't want to teach. Up to here, my rectifier or separation circuit, the concept complete correct. We are trying to stop here. Last point is how to understand active filters. Give me a time of 20 minutes to give the idea about how to analyze the active filter transfer functions. That is more important. Then after discussion of that, we'll take a break. Okay. So we'll get the transfer function techniques. You'll get like a video for you where you can understand how the transfer function can be solved for every circuit. Okay. Here I'm not solving any circuits, nothing. I'll explain you the transfer function recognition for you. So that anybody give a question for you, just you'll find out the transfer function by using amplifier concept. Then see that whether the transfer function is matching with filter. That is important for my class. So that's why shortcut tricks I'll explain. Give me 15 to 20 minutes time. So that we'll stop this area. We'll go for a new area in the next concept. Taking half an hour break, we'll start a fresh area. So please complete it. Just I need only 15 minutes to give you good techniques for you in active filters. Just 15 minutes I'll teach. I think today the video, after this video, you may get 2 more videos. That is called active filters. Okay? Nearly 4 to 5 hours class I have taken for that. So please don't copy that 4 to 5 hours class in your notes. Whatever the techniques I'm telling that you copy. That is more than enough for this area. Okay? The questions will be very easy. Just if you can understand the procedure, how he's doing, the techniques are easy for you. So just give me a shortcut tricks for that. Summary show here. Op-amp 1 equation repeat. Operational amplifier 1 equation. I think you're asking here, Samresh. Nothing is there. Here I have taken this current as I1 current. This is I2 current. This is I3 current. These 3 currents I made at this point 0. KCL applied. Okay. All the currents are entering. All the currents entering is equal to 0. It's a very simple thing. VIN by R 1 current and VA minus 0 by R, VA minus 0 by R and VA minus 0 by 2R. 3 currents are going. And what I've done is these 2 R's should cancel. Balance करने के लिए by 2 by 2 I applied. That's my mathematics. If you are not interested like that, you do LCMs, all these stories. To make it fast, the calculation techniques, we use balancing techniques. 2 by 2 by 2 if you add, all this becomes 2R. If the 2R goes that side, this is a numerator only. These are sort of mathematics. Okay. Nothing is there. I have done. Simple KCL applied. Just come to the final issue now. With this, I'll stop the concept here. Just 15 minutes, give me time for me to explain you the transfer functions now, which is very valuable for the student to recognize in the exams, the question. Most probably this relations you have to keep in practice always. So this is not a tough area, simple area, active filters. But in the syllabus, one thing I want to tell to the students, previous years around 2019 to 20, okay, there is no word called Shalinki and Butterworth, okay, but they have given simple active filters, means only first order. But in this lecture, I'll show you second order transfer functions also, how to recollect. Okay, in that there will be some Butterworth approximations. Butterworth is not a big topic. Second order also we are studying. So in my video, whatever I'm going to present in recording video, not only teaching the transfer functions, I derived step-by-step total derivations. But the derivations are not required for you, but understanding how the transfer function came, you can see. Only one time I invested the subject knowledge on the active filters. Okay, for every online batches, I'm giving that video so that whenever you have free time, you can just watch it. So that each and everything will be clear in the model. But you don't read all the things, just understand the procedure. And exam case I know what are the results. I'll just start out some results in the board when I'm teaching. You just to practice the equations. Butterworth means what? What is that the condition we have to take? How much the gain is required? That all things you have to practice. In the video, you'll get a clarity in that. Just watch that video, you'll get all these conditions. But in this class, I'm not teaching all the techniques. I'm teaching only the transfer functions how to recognize. Because we have nearly 5 filters. Low pass, high pass, band reject, all pass. These 5 techniques I'll explain you as a table form now. So if you complete this, just keep the final heading, which I'm giving a oral explanation for this. There is a 10th topic, we'll finish by a concept called active filters. I'm not teaching the complete view for you, just I'm giving the tricks for you. In my video, you can listen total techniques, all these things. So just I'm giving the overview of this concept. Overview is important. See here. First of all, I'll write here the name as filter. I'll write. Take a table form technique. Filter, you write. Next, keep a column. Filter. After that, the most important thing is transfer functions. Transfer function, how to recognize. The next is poles and zeros. How many poles are there? How many zeros are there? The shortcut trick will help the student to revise the concept very quickly in the subject. Okay, this one table form I'll explain you. Then in my recording video, if you want, you can see all the circuit designs. How I made low pass, high pass, band reject, all pass, all these things you can see in my video and practice it. So first filter is low pass. First you will have a knowledge. Low pass. First is a low pass. Low pass is very simple. The filter you see like this. First the resistor will be there, R. Next you will see a capacitor. Whenever you see the circuits like this, it is called low pass circuit. The R and C components. C should be in shunt, R should be in series. We call it as low pass. This is called first order low pass. First order low pass, whenever you get, the transfer function has to be remembered like this. The transfer function will be K by S plus omega N. This is the generalized shape which you must get. That means if you solve this transfer function, the shape will be like this. K by S plus omega N. I will teach here active filters I'm teaching. So anywhere you take, why the name came active means I'm going to join an op amp to this active filter. I'm going to join an op amp to this passive filter. That will become active filter, nothing more than that. That active device will give some gain called as K. This K, if you want, active filters I'll use it. Because K is nothing but a gain. And remaining things will come from this circuit. So this is called trans function of a low pass. First order it is. Okay? This is called first order trans function. First order trans function. First order trans function should be like this. Next will be same circuit. Suppose if I take R and C. And again I connected R and C. Like this, if you make second order, we call this as second order. Whenever you make second order, we have used a topology called as Shalem-Key topology we are using. Shalem-Key topology we use for designing this concept. So what do you mean by Shalem-Key topology? How I have used? You can see my recording video. There you will understand it. Shalem-Key topology का meaning क्या है? How the design have done it. So this is called Shalem-Key topology in our syllabus. ये structure को मैं op amp से Shalem-Key topology जैसे design करता हूँ. So that we get some analysis for this. Majendra, I think that video is around 4 hours. I think that 4 hours don't write in the notes. Okay, headache आ जाएगा आपको. Just you write only these things in your notes. Okay, that is only meant for understanding the conclusions. You just write only the conclusions of the video what I am teaching. Because elaborately I taught the class to understand the complete view of the active filters. Okay, only results you practice it. For every topic some results I said, and I made the star marks in the board. That points you take it as a conclusions and write. If you want, you take 2 pages gap again and write each design का low pass diagram लिखकर results लिखो. High pass results like that you write. After this 2-3 pages gap रखो. Don't write the complete content whatever I taught 4 hours. Okay, take only the extraction from that. That is important for GATE student. So anyway, I am giving some results for that ideas. So this is called a Shalem-Key topology device. We are designing this technique. So what is the trans function you must get after designing the Shalem-Key filter is that shape should come as K by S square plus 2 eta omega n s plus omega n square. So you have to recollect this trans function whatever you derive, it should come in this shape called second order trans function we call this as. You should have the standard basics first. Okay, K by same constant divided by S square will come because you have taken 2 low pass filters plus 2 eta omega n s plus omega n square. Eta we call it as a damping coefficient and the damping coefficient will decide the filter approximations called Butterworth. Okay, in Butterworth what we have done is nothing is there. 2 eta, whatever we have taken 2 eta, we have considered it as a root 2. This is called Butterworth approximations. This is called Butterworth. Butterworth approximation. Nothing is there. The damping coefficient, whatever you have, that person Butterworth has taken an approximation of root 2. That is 1.414 he has taken. Then by that how the results will come, all these things you can see in my video. Okay, how I extracted the formulas. Here I am not interested to show all the stories. So this is my concept. So this is called for second order. This is called first order. You take this as a second order. Summary I am telling you how to design the circuits. This is second order. This is first order. In exams we have only 2 orders. So how many poles are there? How many zeros are there? Means for this only 1 pole is there. You can see. And for second order we have 2 poles are there. 2 poles. There's 1 pole and 2 poles are there. Okay. What is the meaning of a pole? Means denominators if you say S square, we have 2 poles. Numerator if you have S, we'll have zeros, but we don't have any zeros. So that is called recollection for a low pass. If I take third order, suppose we'll have 3 poles, we don't have any zeros. That is called low pass techniques. So this is the beautiness how to recollect. If I give any circuit roughly, I can design it, I can calculate my trans function. Just I'll check that orally whether this trans function matches. I say that it's a low pass. That is the simple meaning about this concept. Okay. Whenever you have free time, you can listen to the active filter video and 2-3 pages you keep gap after this lecture. That the content you write in that concept. I don't want to teach circuit diagram. I don't want to take results. That is your job. From the recording video you do it. Here only results and explain for you. So 3 pages gap required at least to write all the conclusions in your notes. So because your circuit designs also not explaining, only designs I'm showing like this. Second point, high pass is the next idea. You have to listen in my video. High pass. So high pass using op amp, how I design, you write in your notes in that gap. So here only passive filter wise, if you see, it looks like this. 1C and 1R. It looks like this. The structure will be like this. We are attaching to the op amps. High pass, whenever you take, the trans function will change. The trans function for this topic is K will be the gain, but you will get S by S plus omega n. So these are all called references for me. Whether your filter is giving this trans function or not, for student will have that knowledge. That's why this knowledge practice curve. What is the difference between this topic and this topic is here we are getting 1 0 and 1 pole in this concept. There we got only 1 pole, no zeros. But in high pass, 1 0, 1 pole. 1 pole is there means 1 0 is required for it. That is the technique. Yeah, both generally active filters will work under stable conditions. So all the poles you see on the left side only. Right side if the pole comes, what happens? The filter will become unstable. So they all comes on the left side only. K S by S plus omega n. So this is your first order concept. This is called first order. So if you want second order means we have to take capacitor C, resistor R. This is VIN. And we have one more capacitor C and one more R. If I design using Shalem-Key filter again, here also I have given the knowledge about Shalem-Key filter. I'll apply a technique of Shalem-Key topology so that your trans function will come as K into S square by S square plus 2 eta omega n s plus omega n square. This is called second order. So in that Butterworth approximation is always this one. Everywhere Butterworth approximation is root 12. That's called Butterworth approximations. In the exam I think they never ask you more than Butterworth because syllabus mein Butterworth diya, but there are so many approximations are there. Chebyshev filters they'll say, Butterworth filters, okay? There are some other filters are there, but we are not required all these stories. Only Butterworth ka meaning 2 eta, whatever you see, it should be root 2, okay? And 2 eta, other name is 2 eta can also be called 1 by q we call. 2 eta can also be called as 1 by q. Q is nothing but quality factor. These all things I have explained as introduction basics. What is a quality factor? All these issues I taught you step by step in my video. You just listen whenever you have free time, you listen that. You get the basics first to understand this area in the class. So anyway, this completes the story. Here we have 1 pole and 1 0 is there. Here we have 2 poles. Second order made 2 poles. 2 zeros are there. So 2 poles, 2 zeros, 1 pole, 1 0. Okay. This is the actual story about how to recognize any filter after calculation, my filter designs. So I have this knowledge in the notes. After that, don't forget to keep 3 pages gap. Okay. 1 page means in my sense, both sides leave it as 1 page because you have to draw the diagrams, you have to write the extraction result formulas by seeing the recording video. So take 3 pages gap. all these things. Just to get a knowledge for the student, I explain in that manner. So only you design low pass circuits, first order, second order, and just see the trans functions. Like that you make your notes. Otherwise it takes a lot of time to practice that session for you. Okay, unnecessarily don't waste the time. It's unnecessary waste of time for you. So if you have free time, whenever you have free time, you can listen it, all the points. Our main job is to result-oriented practice is required in GATE exams. So this is important. GATE practice के लिए logic is important. So this completes my 2 filters. We have 3 more filters I'll explain. 3 more results I'll explain. I'll stop this analysis. Just 10 more minutes if you can wait. We'll finish off and we'll take a complete half an hour break. Then we'll start a new module today. That's the final session for today class. Our time should be completed today. Tomorrow morning is a small practice on remaining topics and we'll start the negative feedback and first tomorrow class. So we are going in a particular mode where the syllabus is going to complete by Saturday. Perfectly Saturday हम class complete कर रहे हैं. Okay? So we don't have any burden on the concept now. The next class is very important. Non-linear applications are most important. Okay? 100% there is a guarantee that one question will come from that area. That much important the topic. Let us complete in a smooth manner in the next lectures. Each and every topic in a smooth manner will complete the techniques. So let me complete the final slide so that we can take a break. Last slide. That is same table form we have to write again. Filter, trans function, poles and zeros again. Again copy the same. I think you are writing table form. Page is completed. Next page may again write like this. Next page you write again. Next page again you write filter. Filter one side. Next you write trans function. Next you write poles and zeros. Poles and zeros. So you can see here concept number 3 I am starting called band pass filter. Band pass filter. What is the meaning of a band pass filter? Is nothing is there a cascading of high pass filter with a low pass filter. If you have 2 systems, if you take low pass and high pass, who will cascade like this? That will become band pass filters. First the high pass you have to take, next you have to interconnect with the low pass circuit. That mechanism is called band pass. So what is the trans function for this is? The trans function will come as simply k into s by s square plus 2 eta omega n s plus omega n square. If you say correctly, band pass filter is giving second order trans function because we have used 2 first order systems in cascading. That's why we get the second order trans function. Okay. Only thing is numerator will not get s square like high pass filter. We will get only s because s is in high pass, but low pass we don't have s. So s into 1 will become s. So this trick is called as band pass trans function. You say like this trans function. So you can write here the meaning is 2 poles are required, 2 poles, but 1 0 we can recognize that is a band pass filter. Recognition is this one, band pass techniques. And coming to the 4th one, band reject filter. Band reject filter. What is band reject filter is? Here we are going to summation the filters, high pass filter and low pass filter. We are going to add it. Here the combination is addition. We have to previously multiplication we have done. Band reject if you want, you have to add it with the same input. Okay, same input you have to add. Then the answer will come as trans function will be s plus k by s plus omega n. If you observe that this trans function we are not getting second order again. We are getting only first order because we are adding it. When you add 2 filters, then s by s plus omega n is high pass filter. K by s plus omega n is low pass filter. If s plus omega n is common, then s plus k by s plus omega n will come. So this is called addition trick. So where you see here also 1 0 will be there and 1 pole will be there in the concept. So 1 0 1 pole will be there in this concept. The last one we have is all pass filter is there. All pass filter. This all pass filter is a combination of 3 filters. Low pass filter, high pass filter, and it's a band pass filter. So 3 filters combination. So 3 filters we have to add. Low pass filter, high pass filter, band pass. All these 3 things if you add, you will get all pass technique, which is coming to be 1 plus s. 1 plus s into SRC will get. SRC. I think negative sign will come here. 1 minus SRC by 1 plus SRC. If you see clearly this concept, you will get the same pole and 0 will look same. Both are images. But the 1 pole, 1 0, how they should look is, if you have a sigma j omega axis, if you have a pole on the left side, we are getting pole, the 0 should have the same magnitude wise, they should be equidistant. If you recognize like this, we call it as all pass filters. We call the pole how much it is on the left side from horizon should be 0 should be on the same side. Maybe this trans function is correct for that. So if you take magnitude wise, the answer will be 1 for it, trans function. So this is the style of trans function, where here also we are seeing 1 pole and 1 0. And in the exam point of view, this filter is most important filter. So in my recording video, correctly understand how I done these filters. All pass is very, very important topic. So in the notes, you write properly that all pass filter, whatever I explain, you write properly that content here and practice that filter how I designed it. Okay. So this is about the total story about all pass filter techniques, which you have to recollect like that in the exam point of view. So the extra 3 pages is meant for your work. From my recording video, you can learn from that. And please copy all the circuits so that this topic will fulfill your knowledge. Okay. So with this, I'm stopping my content about mathematical operations. In the next video is my final video on op-amps. That is called non-linear applications. We have covered everything smoothly. Linear area is covered 100%. Everything we covered. Only one area is remaining of non-linear area. That is my last class for today. So let us complete this and smoothly we'll start off with the break. It is now 10:15 hore. So shall we start around 10:45 like that we'll start the class. Half an hour you can take break. Nicely 10:45 we'll start a new topic today. That is non-linear applications. So take a break up to 10:45. 10:45 AM. So the break time is up to 10:45. You can take a break. So I'm leaving. You can take up to here. Roy is asking how you have taken 0 and pole. Nothing is there here. Suppose you have numerator s and denominator s square like this. Okay. Numerators we call zeros actually. Denominators we call it as poles. Whenever I see s square, I'm telling you that there are two poles. Whenever I'm saying numerator as 1s, I'm saying 1 0. So